Alright, the second topic, displacement, velocity, and acceleration. This topic is very, very important. It is as important as the trunk of a tree. So in this topic, you have to clarify or know the difference of displacement and distance. Also, velocity and speed. So what is displacement? The displacement is only determined by its starting position and its ending position. However, for distance is the path, the object, the total path actually. Yes, it's a total path. The object covered. Let me give you a very simple example. Imagine this is Frisco. This is Plano. Yeah. My mom is in a hurry, so she wanna reach Plano as fast as she could. So she's decided to go to Plano in a straight line. This is not straight, but it's basically a straight line, right? Because the shortest distance between 2 points is a straight line. This straight line is the displacement. Displacement. But if my mom think like this, oh, I'm hungry. I suppose she stop in a random store like KFC. Yeah, let's use KFC between Frisco and Plano. So my path's supposed to go like this: from Frisco to a KFC and then from KFC to Plano. The displacement is still from Frisco to Plano, this straight line. The displacement is still this straight line. However, your distance is no longer a straight line as the first situation. Your distance is this part of the path. I would just use x1 plus this part of the road. I would just use x2. For the first situation, if you just want to arrive at Plano as fast as you want, you just go from Frisco to Plano in a straight line. So you're in the first situation, I'll just use S1. Your displacement is just from Frisco, I just use F, to Plano. It is also equals to your distance. However, in second situation, I will just use S2. Your displacement is still F2P from Frisco to Plano. Oh, by the way, this is a vector, Frisco to Plano. But it is no longer equals to the distance. Your distance is actually the first part of road x1 plus x2. Also, the distance, and then it's very easy for you to figure out that your distance is bigger than your displacement. In this situation, in displacement. But in situation one, in the first situation, your displacement is equal to the distance. So that we can conclude that your distance will always be bigger than or equal to your displacement. Alright, now let's talk about velocity and speed. Both of them represented how fast an object travels in a period of time. However, velocity is a vector, speed is a scalar. The simple formula for velocity is displacement. I would just use x over time. For speed, is the distance it travels over time. Let me give you an example in a very easy way. This is Frisco. This is Plano. You decide to travel from Frisco to Plano in a pathway like this. Oh, how fun. Your speed is the distance it travels. The distance is just described. Over the time you took to travel from Frisco to Plano in this, in this crap, in this pathway. So your speed is just your distance over this t. Your velocity, the, the velocity is equal to x over t. The t is still this t because you use this amount of time. Your t is still this t, because this is the amount of time you took to travel from Frisco to Plano. However, the formula for velocity is displacement over time. Your displacement is still the straight line between Frisco to Plano. This part, the straight line. So this is so your velocity is actually smaller than your distance over t. And then we can conclude that your velocity can be smaller than or equal to your speed. Because when you travel from Frisco to Plano in this pathway, like exactly equal to your displacement, your velocity x over t is actually equal to distance over t, which is equal to x over t.